Yeah, well, a tsunami is formed by the seafloor moving vertically due to a large earthquake. You need a very energetic earthquake to really make a significant change in the sea level, and we've certainly seen that today with magnitude 8.8 is a very intense earthquake. And that has pushed the sea level up above the rupture in the sea floor, and that wave then propagates outward from that rupture across the ocean in all directions.
When you're seeing the pictures that we're seeing on the screen now, the force of the water, can you just give us an indication of just how strong that force of water coming in on land is? Nothing can stand up to it. No,
that's exactly right. We've had observations already measured on the Japanese east coast of waves of 7.3 metres above normal sea level. There may well be higher spots where there aren't gauges, but that is an enormous wave, and what people have to bear in mind is that a tsunami wave is quite different from a normal wind wave, which goes up and down in a matter of seconds. The tsunami wave has a wavelength that can be hundreds of metres, so it's an enormous volume of water. It rises 7 metres and may stay up as water pours in at that height for 10 to 15 minutes before it goes down again. So it's an enormous volume of water, and that's why the force is so great.
We've seen a number of devastating earthquakes over the past few weeks. Only a couple of weeks ago, the terrible earthquake in Christchurch, now this in Tokyo. Why are we seeing so much seismic activity now?
I don't know that anybody could answer that. Unfortunately, we don't know how to forecast when earthquakes are going to happen. This is all around the Ring of Fire, which has existed around the Pacific for a very long time. Its activity fluctuates with time. I'm not a seismologist, but I don't think anybody is really capable of predicting when these peaks in activity are going to happen. We just have to react as quickly as we can when it does happen.
Well, Chris, you are from the Australian Tsunami Warning Centre. I'm just wondering just how much warning it is possible to give. What sort of timings do you have to tell people, you know what, a tsunami is on its way? Is it seconds? Is it minutes? What?
Yeah, no, it's certainly not seconds. It's a sad fact that it does take some minutes for the earthquake signal to travel through the Earth's crust to reach the seismographs and for that information about the magnitude of an earthquake to be assessed. And that's usually around 5 to 10 minutes is what's needed to do that accurately. Then, of course, warning has to be formulated and distributed. So it's very, very difficult to give useful warnings to anybody who's less than 30 minutes tsunami travel time away from the earthquake.